Okay, Eg13. Particle of mass 3 kilos rests on a rough horizontal table, and coefficient of friction is 0.2. It's connected by a light inextensible string passing over a smooth fixed pulley at the edge of a table to a particle of mass 2 kilos which hangs freely. Find the acceleration of the system when it's released from rest. Find also the force exerted on the pulley. Okay. So here's my table. So I've got a 3 kilogram mass that is sitting there, and down here, I call that A and that B. This is 2G. Oops, keep forgetting to change colour for my forces. And there'll be equal and opposite tensions there. I'll have a tension there, which is equal and opposite. This would be 3G. It would have a reaction force, and it's rough. Now, if that's released from rest, there's only two things that can happen. Either nothing will happen and the whole system stays in equilibrium, but it's telling us it's going to have an acceleration, so that will only happen in those directions, which means the friction force is going to act in that direction there. So if we consider all the action that we've got on A first of all, so on A, so Newton's second law is going to apply in the horizontal plane, so we have N2L there, which will be T minus F equals 3A. So that's my first equation. The sum of the y components are going to equal 0. There's no vertical motion. So we've got equilibrium there, which will give us R minus 3G equals 0. And we also know that F equals mu R when mu is 0.2. So that is all the resolving and all the force analysis we can do on A. When it comes to B, direction of motion is positive, so I'm going to have Newton's second law again, 2G minus the tension in the string is equal to the mass times the acceleration. So the tension is the same in the whole system, and the acceleration is the same in the whole system. So the first thing they want us to do is work out what that acceleration is. So we've done all the mechanics, it's now over to algebra. So I need to end up either in equation 1 or equation 2. If I can get F in there, then I can add equation 1 and 4, sorry, not 2. I can add those two together, which will eliminate the tensions. I can get F by finding R from 2, putting it in 3, there we go. So from 2, R is 3G. In 3, F equals 0.2 times 3G, which will be 0.6 G. Put that in 1. I have T minus 0.6 G equals 3A. So if I call that now equation 5, I can add 4 and 5 together and it will eliminate T. So 4 plus 5, I have 2G minus 0.6G, so that's going to be 1.4 G equals, the T's cancel, and then on this side I'm going to have 5A. Yeah, it's this equation here, two equations that I'm adding that one together with that one. So I get 1.4 G equals 5A, so A equals 1.4 G over 5. So on our calculator, 1.4 A over 5, 2.744, which is 2.7 meters per second squared to 2 sig fig. So that's my acceleration. Find the acceleration of the system when it's released from rest. Done. Find also the force exerted on the pulley. Okay. So this one's a little bit more complicated because we've got both forces acting at an angle rather than acting in the same direction. So you could recognize we've got some symmetry going on there, but in case you don't, let's set this up in an unambiguous way. So we've got our pulley and we've got a force T, which we've calculated. No, we haven't. Let's go back and calculate T. We're going to need that. So that's my acceleration. Put that in, which one shall I put that in? I'll put it in 5. So in 5, T will be 3 lots of 2.744, which is the acceleration, plus 0.6 G. So back on the calculator, I've still got the 2.744 times 3 equals that, and then add 0.6 alpha A. So the tension is 14.112. Sorry about the dog. Lady, shut up. So the tension in the string is 14.112. Back to this. So I've got the tension there, and I've got the tension there, perpendicular to it, and I'm going to have some force which is going to be the resultant of those, the force on the pulley. The system is in equilibrium. The pulley system is in equilibrium. It's not moving. So the sum of the x forces equals 0. So the x component, here you're going to have r cos theta minus t, which we know, equals 0. And the sum of the y components, you have r sine theta minus t equals 0. So from these I can rearrange them, and I'll get I write it r sine theta equals t, and r cos theta equals t. I've written them with the sign first because of a cunning plan. So if I call that equation 1, that equation 2, if I divide those, so if I do equation 1 divided by equation 2, what's going to happen is that the r's will cancel, t's will cancel, and sine over cos is tan. So I get tan of theta equals 1. Remember, because those t's are cancelled, doesn't mean they've disappeared, it means they go into each other once. So tan theta is 1. I know that the angle, which gives you 1 out of tan, is 45 degrees. So that angle is 45 degrees. That now allows me to work out what t is. So if I put that in 1, sorry, r, I know what t is. R sine 45 equals T, which we worked out to be 14.112. So R is 14.112 divided by sine 45. So on my calculator, 14.112 divided by sine 45 equals 19.957, which to two significant figures is going to be 20 newtons. So the force exerted on the pulley is a 20 Newton force, and that will be acting to counterbalance that at 45 degrees to the horizontal. So that bit is actually more work or more complicated than the starting point of that, the Newton's second law work.